So, we, okay. Let me go for the concept and the objectives of Nancy. This is the most scaring slide with several text, actually, but this is the only one. The overall aim of Nancy is to introduce a secure and intelligent architecture for the beyond fifth generation wireless network. It has three main technologies, namely AI, blockchain, and multiple access edge computing. And based on this technology, we want to provide intelligent resource management, flexible networking, and orchestration. To do this, we propose a novel architecture that supports point-to-point connectivity, device-to-device connectivity, mesh networking, and relay-based connectivity, as well as some medium access mobile management and resource allocation design. To make the most of our architecture, we jointly optimize mid-haul and front-haul. And our vision is through distributed intelligence to transform the network to a low-power computer. In this direction, we support end-to-end personalization, multi-tenancy, and perpetual protection. Here is the nutshell of Nancy. As you can see, in Nancy, we are examining three usage scenarios. The first one is a front-haul network of a fixed topology. The second, advanced coverage expansion. And the third, advanced connectivity of mobile nodes. In the first scenario, you can see a coordinate multiple access connectivity framework where the end user communicate with two base stations. The base stations may be commercial or non-commercial, belonging to the same provider or to different ones. In the second one, in the advanced coverage expansion, again, you have two access points, a base station and here in the figure a laptop. That one is commercial and the other one is non-commercial. And in the third one, you have mobile nodes that can serve as an intermediate or as a signal strengtheners. To achieve this, the main technology enablers of Nancy are multiple access edge computing, blockchain, post-quantum cryptography, and caching offloading policing. Moreover, as a key technology modules, we have artificial intelligence, orchestration, next generation SDN, and AI virtualization. What we want to achieve is an energy efficiency boost of the whole network that may even surpass 20%. We want high security and privacy, low latency, ultra high reliability, flexible scalability, ultra high availability, 100-meter end-to-end range expansion, AI reusability, and finally, to minimize the ownership cost. The fundamental characteristic that we have in Nancy is blockchain modeling. The new attacks that we have, new models, sell and grant-free access, semantic communication, and smart pricing. So, all in all, our work is organized in three pillars. The first one is the blockchain radio access network that will allow excellence in terms of privacy and will support dynamic scalability, high security and privacy. AI-based wireless radio access network orchestration in order to have ultra-reliable connectivity and high energy efficiency, reaching even the Pareto optimal here, and mobile edge computing in order to have almost zero latency and high computational capabilities at the end. In other words, we want to bring intelligence at the end. Here you can see the different actions that we are going to take in order to achieve these objectives. For example, we will going to design a blockchain radio access network, new grant and sell-free mechanism, concession mechanism, distributed and decentralized blockchain, as well as smart pricing for the blockchain radio access network. For the AI-based orchestration, we are going to have machine learning-based joint node association and resource allocation strategies, model-based and data-driven machine learning-based optimization, machine learning-based slice initiation, and federated learning-based anomaly detection and healing and self-recovery. While for the almost zero latency target, we are going to have adjustable to make resource and run functions, exploit the trade-off between B-run performance and resource usage, resource-aware provisioning mechanism, and offloading policing as well as social-aware caching. The project has in total 15 results that will be demonstrating in 5 demonstrators, 2 in-lab testbeds and 2 out-of-lab testbeds. Let me go to the results and our overall approach. The 15 results that we have is, first of all, the design of the blockchain radio access network architecture, a novel trustworthy grant and self-recuperative access mechanism, a novel security and privacy toolbox that contains lightweight concession mechanism and decentralized blockchain components, realistic blockchain and attack models, and an experimental validating blockchain radio access theoretical framework that present the performance envelope of our approach, a novel quantum key distribution mechanism to boost the end-user privacy, smart pricing policies, AI-based blockchain radio access network orchestration with slicer initiators, a novel AI virtualizer for underutilizing computation and communication resource exploitation, novel self-involving AI model orchestration, experimental-driven reinforcement learning optimization of the B-run, semantic and goal-oriented communication, an explainable AI framework, next-generation software-defined network-enabled MEC for autonomous anomaly detection, self-healing, and self-recovery, a computational offloading mechanism with a novel resource-aware provisioning scaling mechanism and a novel battery as well as computational capabilities-aware offloading policies, and finally, a user-centric caching mechanism. These results will be organized in 3 enabling innovations, namely blockchain radio access network towards Pareto optimal AI-based resource orchestration and management, and MEC-enabled experimental-driven modeling and optimization, and which will be initially demonstrating in 2 testbeds, and then they will be create 3 innovations: security and resilient blockchain functions, personalized multi-tenant connection function, and a joint AI-based resource allocation and orchestration-based and semantic communication functionalities that will be demonstrating in 3 demonstrators. They will be ORAN compliance, and here, as my last slide, you can see the overall Nancy architecture. You can see that it is based on the basic architecture of ORAN, and then all of the components of Nancy have a specific location here. Thank you very much. I hope that I was on time.